Welcome to our six-part series on psychology and artificial intelligence. We're about halfway through. The last episode, episode 2, was hope, hype, and disappointment of AI. And tonight's, or this afternoon, depending on where you are, this afternoon where I am, it is episode 3. The cognitive dissonance of artificial intelligence, or if you will, I've coined a little term, AICD. Kind of sounds like ADD, but it's not that far off. Because if you connect to or even half as keyed in as I am of all the articles that are out, every day new articles about artificial intelligence, and all the different things that are being said and the claims, and it's become a real issue in our time, especially as we've talked and pointed out during our last episode. So do you feel sometimes that your head is about to explode? Just too much, you're hearing too much, it's being pushed at you? Well, I certainly do. And that's actually, there's actually a term for that feeling, cognitive dissonance. And the idea is that when you have two things going on and you're presented with two things that appear to be different, and they're supposed to be the same thing, but you have two ideas about the reality and they're not consistent with each other, people will try to merge them into one consistent conception. And sometimes you can do that, and sometimes you can't. And why you might not be able to. For instance, if you have an idea what something is, and now some authority comes along and says, no, actually, you're mistaken. This is what it really is. And if that person has enough authority and with you, then you might throw out the old idea and embrace the new one. But what happens if the original idea is so built into you, it's so much intuitive to you, that the new idea, even though it doesn't mesh with that, can't be dispensed, it can't overpower it. So the idea is, what happens psychologically is you somehow try to merge it together, merge the two together. And that results in what you might call a cognitive chimera, something that's neither this nor that. And such things can't really reflect reality. So, and that is a very uncomfortable feeling. Now, people say all kinds of things about AI that engender more or less of this feeling of experience, I should say, of cognitive dissonance. Sometimes people say entirely common sense. For instance, Dr. Bandy once described AI as, it's very simple, in a very common sense way. It's when you can talk to a machine and it understands what you says and has enough intelligence to go out and do what you asked. That's a common sense thing. We all relate to that. Now, that doesn't cause any cognitive dissonance at all, because it's exactly what we'd expect an artificial intelligence to be. But then there's a whole category of things people say about them that are really metaphors. For instance, smart home. Well, people have been talking about smart home since there were computers at all. And it was a metaphor, because once people had a digital device like a microprocessor, or even earlier than that, to do logic with relays, ladder logic, we could say that by analogy, as a metaphor, the house was smarter, because when you turned on a switch, it just didn't hard code something to turn on. It might go through a little logic. In one context, do this, and in another context, do that. Oh, that's smart. And that's fine. That doesn't cause much cognitive dissonance, because it's just the use of a term in a metaphorical way. Then we have people expressing their opinion. And again, depending on how much authority we have, it may or may not cause us cognitive dissonance. For instance, we had Sundar Pichai, we've been referring to his quote that artificial intelligence, in his opinion, which he says, in my opinion, I think it's going to be bigger than the internet, electricity, and even fire. Well, okay, that's interesting. It doesn't necessarily cause cognitive dissonance, although because of who he said it, it maybe borders on hype a little bit. Another one might be Jan LeCun, who we've also quoted, one of the fathers of machine learning, who said that he believes that machine learning will be absolutely sufficient as a technology to take the enterprise of artificial intelligence all the way to artificial general intelligence. Now, artificial general intelligence is a term that's been invented for the sake of really referring now what you might call the common sense notion of AI, about machines that understand what you tell them and can do it. So his opinion is that this technology that he's been a pioneer of will be sufficient to get there. Well, okay. He may be right about that. He may be wrong. The fact that he's won the Turing Prize gives him a lot of gravitas. And for a lot of people, though, that starts to be uncomfortable. It starts to create a little bit of this uncomfortable notion, because machine learning today doesn't look like that. And he doesn't present a roadmap or say, this is how we're going to do it. He just, I think. Well, it's an opinion. And then we have the notion of talking about the AI, but using a little bit artistic license. And that's okay. When you want to be a little creative, you want to bend the language a little bit. In some ways, even the term AGI is taking a little bit of artistic license, because you're saying then that by contrast, if you take the G out of it, it's still AI. But if you take the generality after artificial intelligence, not sure in what sense it's intelligent anymore. Actually, we'll talk about that notion of generality a little bit more, a little bit later. And then, of course, we have wishful thinking. Wishful thinking is maybe those who are enthused about artificial intelligence, and they make statements like, it's almost here, just around the corner. And people do that every day. I referred to in an earlier talk about a person I met in a store who was starting, once he found out that I was involved in AI, started to get very enthusiastic, that he thought we were just on the verge of living the life of the Jetsons, with Rosie the robot running around the house and cleaning everything up. And I thought I like to remember that one, because he said we just about have everything except flying cars. But in reality, flying cars are already in the air, so to speak. But in terms of Rosie the robot, well, I think it's wishful thinking on his part. And then we go even beyond that to magical thinking. And we'll actually, in our later parts of the series, we'll go into that. In fact, I think episode 5 or 6, it actually is entitled Magical Thinking. But magical thinking is when people come out and they say things about AI, like if you build a language model big enough, or you build, for that matter, a computer big enough, it will suddenly spontaneously develop consciousness and intelligence and become an intelligent entity or a sentient sapient entity. Again, no, that's like one thing magically changing in the other. Again, no evidence is ever provided on these statements. And yet some pretty authoritative people in the field do make statements like that all the time. Of course, then we have just the sheer hype. And you know that we see so much of that out there that I have felt compelled to start launching a project to formally debunk a lot of the things that you hear out there all the time. And on this site, Forward to the Future, we have our hypometer, and we talk about things that that are just really, hype is said to try to get people excited. I'll give you, when somebody will take something and for instance, a great example of hype, we haven't put this one up, this is really calling for a hypometer article. Just this week, some people looked at another deep learning, I think from OpenAI. They came up with a very interesting program, an algorithm that based on, you can ask it to draw me a picture of a monkey, and it goes through, it had been learned on millions and millions of things, and they've done both a cross correlation of languages and people talking about images and the images, so that it does a pretty good job on that. And that's cool. Again, I don't know what's AI about it, because again, there's no knowledge or intelligence there, but it's an interesting utility, and it has a language front end But it's kind of like Siri's language front-end. Siri doesn't understand what you say, but if you say certain things that within the context, it can parse that and execute a function and do something useful. In this case, the thing creates a picture. Well, here's where the hype comes in. So it turns out that in delving in its operation, the algorithm in its process of converting the ASCII ones and zeros of the input creates an intermediate arrangements of ones and zeros. And when you look at that, encased in those intermediate things, you'd still find some syllables that came from the actual input and spaces between them. And people say, it's a language. So, oh my gosh, it's a language. And AI created its own language. And it creates a furor on the internet of hype where people were grabbing onto this. And by the way, it's strictly not true that it was a language, okay? For technical reasons, it wasn't a language because language is a medium of communications, and there was nothing being communicating here. It was just an intermediate arrangement of information storage where it was converting one pattern of information that it had progressed to another pattern. Not a language, but it looked like a language, kind of, except it wasn't intelligible by a human mind the way the inputs were intelligible by a human mind. So now we have people all over the web saying, oh my gosh, it's now creating its own language. And immediately they keep talking about people like Stephen Hawking who said, we need to be careful of this AI because it could take over. And you get articles with pictures of the Terminator all over the place. I mean, the internet went wild. That's hype. And it's hype, I think, primarily designed by the people on the web to get people to come and read their articles and blog sites and everything else. It's hype, it's clickbait, okay, essentially. And finally, there's willful deception. Now, willful deception is like Sophia the robot, who the purveyors of Sophia the robot went out and arranged for her to become a citizen of Saudi Arabia and got her to be the first non-human recipient of an award. And then they had things that articles say, ah, yes, now say Sophia says she wants to have children. Now, come on. It's a chatbot inside of an audio animatronic mannequin. But some people apparently are taken in. But that's like, P.T. Barnum. It's just showbiz. It's just willful deception. So all these are the kinds of things that people say, and these are engendering this phenomenon of cognitive dissonance, where people try to somehow jam what they expect AI to be to fit somehow on what they're being fed. So it's rampant. AICD is rampant today all over the place, and not only by people who are, journalists or people who are promoting something, their blogs or whatever, but by people who are very intelligent, very educated, and in high places. So here we have an excerpt from an article in Defense News, which is a very conservative technical journal about DoD and defense procurement. And it's talking about a program which, interestingly enough, is named the Skyborg program, which was taken from science fiction. And what the program is to provide some processing, a program, an application, an app, if you will, that may probably have some machine learning elements in there, along with a lot of other programming and interfaces, to help offload the workload of a fighter pilot, and particularly allow a fighter pilot to control a second aircraft, which would essentially be a drone flying alongside of him. Now, of course, they do machine learning to allow the one plane to follow the other. But again, that's machine learning, and it's like AI in the sense of self-driving cars are AI. But again, that's a real narrow definition of the term, because that's AI like a flock of swallows is, they don't hit each other, right? They fly in beautiful formation, but we don't say that they're intelligent because of it. So, but because it's AI, we start making these statements like it's an intelligent wingman, and it's going to be self-learning and self-assessing artificial intelligence. And it's going to be like R2-D2. R2-D2, of course, was an artificial intelligence that fits our common notion of what an artificial intelligence is, right? Because it understood language. Interestingly enough, R2-D2 did not speak our language, but it clearly understood it. So this is, now here's the question. Does the person who said these things, does he know that this is hype, or is it an honest opinion, or is it just kind of cognitive dissonance in the sense that if this is AI, there must be something like that in there, and maybe we'll see it kind of in the next iteration. So you kind of take the thing that people are calling AI, it doesn't look like AI according to what your intuitive notion of AI is, but you kind of make excuses for it, and you kind of like you're anticipating that it's going to start acting intelligent a little bit down the road, maybe in version 2.0. So it's everywhere. So another way you see it, I think, is in the way we talk about some of the big concerns that people have today about AI / really about machine learning. One of them is AI ethics. And the way this is addressed and talked about, we have AI ethicists, can't say that word, but you know what I'm talking about, people who specialize in AI ethics. Now, what does that mean? They talk about it, and people tend to think about it as though they're talking about the ethics of the AI. Because we're intelligent, that is, human beings are intelligent, and we have ethics, right? But ethics is about your moral principles. But AI, machine learning, are stochastic algorithms. They don't have moral principles, but we talk about them as if they do. So do we think they do, or do we think they don't? We're in an no man's land. We're in cognitive dissonance about it. That's a big deal, AI ethics. Another big deal, explainable AI. We want, and what this is getting at is machine learning come out, we're using machine learning algorithms to make decisions. So they make a decision and they say, okay, you get a loan, you don't get a loan. You get accepted to Harvard, you don't get accepted to Harvard. And people say, why not? Machine learning can't explain why not. Of course it can't. It's a mindless algorithm. Can't explain anything. And yet, we kind of sit around with our hands in the pocket and say, explain yourself. So what are we doing about it? What is the field of AI, explainable AI really about? It's trying to find out, it's a big effort to try to delve into, well, maybe it was in the data that happened. They don't really, see, we have no insight into what's going on inside these algorithms. They're written, they train against the database, they come out with results. But it's no one can really explain how it actually works, not even the people who design the algorithm. And yet we talk about all the time that AI ought to be able to explain itself. And there again, if it was AI in the common sense world, it would be able to explain itself, because humans, when we use our intelligence to make a decision, you say, why? Of course we can explain our reasoning, or mostly. Here's another one. This is a big deal, AI bias. Those, oh my God, those awful algorithms, so biased. No, bias is a characteristic or property that human beings can have. And I think that it's probably fair to say that all human beings have a bias of one set. It's really a point of view, isn't it? A way of looking at things from a certain standpoint, which may be fair or unfair. Really, when we complain about AI bias, we're really complaining about what we think is unfair bias. In other words, it's biased this way and not looking at some other things it should be looking at. So the bias is an unfair bias, but a bias is just point of view. But again, people have points of view. Algorithms do not. So only people can be biased. So AI bias is really about the role that human bias plays in the enterprise of AI. If that's the case, that's how it should be described. But when you start saying it like this, people blame the algorithm. Now, it's not unfair to blame the algorithm designer a little bit, because the algorithm designer may be biased, but then again, he or she may not be biased, but they don't really understand how the algorithm works. Of course, that if you train an AI, a machine learning algorithm, on a data set that consists of language written by humans for humans, then naturally, if there is bias in those humans, and isn't there always to some extent, then the AI app is going to reflect that bias to some extent. And the question again, is it fair or unfair? And if it's coming out with unfair bias, well, how do you control that? Well, one way people try to control it, so they try to purge the data up front. You've heard of data notation, data editing. Let's take out all the bad data. But that's an incredibly labor-intensive practice to do. And if you're going to do that, well, where's the value of the automation anyway? Automation is supposed to make us more productive. So all these are examples of cognitive dissonance. And as you say, it's rife throughout our entire public discourse today about this very important area of AI. So let's see if we can deconstruct it. Let's see if we can figure out what is the mechanism by which this occurs, and can we get our arms around it? And then if we can and understand it better, maybe we can make ourselves, this person, more immune to it. And I'm going to use an example here. So there was a study recently by, and I don't know folks, but this is, I guess these are pretty legit people, Center for Human and Machines at the Max Planck Institute for Human Development, which I think might be here in Florida, I'm not sure. And it raises the concern that when we use these machine learning algorithms to solve problems, like, or to automate decisions like who gets a loan, they come up with certain types of solutions, and that these solutions then in turn kind of make their way into our culture because they become the de facto norm because everybody's doing it. And that is a concern because we're having decisions, we're having things make their way into our everyday culture and activities that come out from algorithms that we don't even understand how they work. And by the way, that's not me. I'm not really a machine learning expert in terms of the algorithm, but I can give you many places you've seen in my writings where I've quoted people are in the insides, like Jerome Vicente, who's VP of AI at Meta now, who flat out says, we don't understand how these things work. And that's a real interesting problem. And the more complicated the algorithms get, the less we understand them. So it was a good article. It was objective. The tone was correct, I thought. But look at the title that somebody gave it. Now, I don't know the original authors gave it this title, but this is the title that was on the news feed on Google. It's what attracted my attention, and I'm sure it attracted a lot of people's attention. So let's decompose the language. Now, in my previous one, a lot of you have seen this is an example whereby we take a concept, and here is a model of the concept of writing, which many of you, if you've seen our demos at New Sapiens, when we're talking about our approach to language cognition, comprehension rather, and machine understanding, we build models of things. And so this was our model of writing. And you can see that, but forget that this was done by a sapiens, just pretend this is a human, okay? Because the process I'm trying to illustrate is absolutely no different in the way we think about things. And in this case, it was a program, but it's doing the same thing. And what it's illustrating is this same bit of model here, call it a concept, call it the concept of the action of writing. So the way the model is put together, it specifies, I think this is the idea of your head. We have this, if you think of writing, you have along with it, your understanding of it includes the things that can write and the things that can be written, and also what might be the effect of that. And then this little dialogue here on the right, you see how on one hand, where there is knowledge, if a person makes a statement, Jeff rides cats to work, and you know what all those words mean, you use that knowledge, you use these connections here, and you can think of these connections as kind of subatomic bonds between subatomic particles to create an atom, or bonds between atoms in terms of binding molecules into more complex molecules is a better analogy, actually. So those bonds determine whether you can take two things together. So in this case, when we said Jeff rides cats to work, you think, well, wait a minute, what can you ride? You can ride horses, you can ride vehicles, you can't ride cats. So you reject it. And what do? You go, ha, that's funny. And I think, by the way, as a side note, I think it is so interesting that when someone makes a statement that fails those fundamental common sense tests, that we think it's funny. It's, in fact, I'm playing with the notion, the theory that humor really has its origins in our emotional response to failed common sense testing. A snail walks into a bar, ha ha, that can't be. Why is that funny? I don't know, because because you're trying to jam things together that don't fit. But the problem with cognitive dissonance is you jam things together that ought not to fit, but you jam them together anyway. That's not funny. It's it's ugly. But so that's step one. That's one thing you can do with the same bit of knowledge, if you will, the same idea of writing. But if you don't have a knowledge of all the words, what we typically do is we turn around the other way and infer, using the same bit of knowledge, the meaning of the unknown word. So in this little dialogue here on the right, if you didn't know what a scooter was, and then you were told Jeff rides scooters to work, and you knew Jeff was a person that passes a test in writing, so then you could infer, and we do this all the time. That's how we get most of our vocabulary, by making these. I don't know what a scooter is, but it's got to either be a vehicle or a horse, if this is what you know about riding. In fact, in a more sophisticated way, we actually have the set of rideable things, which include horses and elephants in India, and any very large animal that could walk around, plus vehicles, and all that would be in that set together. And cats still wouldn't fit in there. Okay, so it would still not fit. So this, by the way, is the G of artificial general intelligence. It's about knowledge, and it's about knowledge by the very definition of what it is. And when you make it real knowledge that's functional knowledge, it is general, because here we're using the same knowledge to do two essentially completely different things. On one hand, we're using it to learn new words. On the other hand, we're validating that somebody said something that was common sense. So that's how, if you can recognize if you've got cognitive dissonance going on here. So going back to this statement, here is a bit of model of knowledge for the action of inventing. And inventing here is a subclass of process. It's a process, has a lot of different steps and a lot of different ingredients that come in, so it's a complicated thing. In order to invent something, you've got to do a lot of, you have to have a lot of smarts, a lot of knowledge, some creativity. You have to have a lot of characteristics. Inventing is not something that's easily done. It's a lot more sophisticated, for instance, than writing. So the effect of inventing is that you create something that ends up in the set of invented things. And in a common context, if you say, if you said that a Tellurian invented a new something, you would guess that a Tellurian was a person of some sort, or group of people, or of some obscure profession. You would infer that it was a person. So again, this is kind of cognitive chemistry in the common context. But if you want to step back in, not out of the common context, but in a broader, more technical concepts, well, you would replace maybe person with anything that had all these characteristics that could invent. So let's say a sapient entity. So maybe the very notion that you have a set, or you entertain that something other than a person could invent, you automatically in your mind create the notion of a sapient entity. It's an abstraction. You can't help but create that set if you entertain the possibility that something other than a person could invent something. And so this statement here, AI inventing, immediately says, oh, it classifies an AI as a sapient entity, and a sapient entity, if it can invent things, has all of these characteristics of intelligence and creativity. Boom, cognitive dissonance. You're imposing, you're going the other way. It was the same mental function that you would have used to infer but going the other way, that a scooter was a vehicle, but this time you're inferring that a AI is a sentient entity, and that this one was a sentient entity because it could invent something. Boom. So that is where cognitive dissonance comes in. You have to be very precise about what can be an inventor to recognize that you're, and then you got to decide, do I think that a machine learning algorithm has all these characters? Well, it doesn't. Most people do. But beware, otherwise you're going to be in this cognitive dissonant state. By the way, this sentence, the second one is just as bad. Passing it on to humans. Passing it on, that expression is short for that means communicated. It communicated it. It invented something and then communicated its invention. So, but machine learning algorithms don't communicate, because communicate means to have an idea, have a knowledge, have something to say, and then encoding it into language, or otherwise demonstrating it to other people so they now understand what you did. So that's not communication, unless you use the word communication in the sense of a communicable disease. Okay, so and maybe in that sense, if you say that it's a communicable disease, okay, I'll accept that. But again, that's a very different meaning. So that's how we use that. That's where humans go wrong, because we're not precisely asking ourselves. We don't really look at the language to say, is this something that really, what does it mean to invent? And that's getting up into what educators and we at New Sapiens, when we're looking at our Sapiens, we're trying to assess their performance. Well, that's a higher level of Bloom's taxonomy here. You can say AI invented something, but what are the ideas behind those words? And again, the concept of invention is rich and multi-layered, multifaceted, it's complex, and it can only be performed by an entity that has many different abilities and talents. So think beyond the grammar, think beyond the immediate reference in the word, and only apply those. I'm going to learn a new concept here, like AI, because it can invent things. It must be intelligent. So much the hype and even the outright deception goes on relies on that, and it creates cognitive dissonance until people get quite confused. They don't necessarily know they're confused. Well, actually, I think most of them, when you feel cognitive dissonance, it's kind of a visceral feeling of confusion. It's not pleasant. So what we're doing at New Sapiens, if you were here last time or saw the video, what we're doing kind of, we don't think that's called cognitive dissonance. As we went back in that previous dialogue about the scooters and the owls and things like that, there was no cognitive dissonance there. It was very clear, and it didn't make any difference as to whether it had been said by a machine or whether it had been said by a human, because there was no really appreciable difference, even way to tell whether a machine had said that. The machine, when its language may be a little stilted, like somebody learning English as a second language, but it would pass. But there was no cognitive dissonance there at all. Nor there was any hype going on. That's simply the way it processes that language, and you couldn't tell it from how a human did. So, as we pointed out last time, going back and seeing why the work we're doing at New Sapiens does not have that cognitive dissonance, and it does have. You can see that if you keep building it along the lines where you are now, it may well, and in fact, we believe it will getting back to the to be conformal with the statement that when they understand what we're telling them and have the intelligence to go do it, you can see that happening. And it's just a matter of a straight line interpolation that you can make. And you don't have to have wishful thinking, and you don't have to have magical thinking, and it doesn't need to be hyped, because Cognitive Sapiens will speak for itself. So as we bring this technology forward, we believe that this phenomenon of AICD will fade away, and that will be a really good thing. And the example, in terms of explaining what's really different and how we got here, is the notion that we didn't try to study the human mind in the sense of duplicating the natural processes by which the human mind goes through that same logic that we demonstrated, we talked about with machines, or I'm sorry, with owls and scooters and riding or inventing. We didn't try to, we weren't able to come up with the same thing, that same end product, that same end dialogue that human would have by emulating or trying to emulate the natural processes that went on in the human brain, because we don't know what they are, okay? And it would be really hard. It is really hard to try to build an artificial brain. Instead, what we've come up with is what we call this cognitive chemistry, that if you take the ideas and you treat them like particles and figure out which ones are the fundamental ones, and then you can put them together in certain ways, and that they have properties that determine what you can put together and what you can't put them together. And I think it's so interesting that we have this term now called synthetic intelligence. I didn't make it up. Actually, I did make it up, but then I found that somebody made it up before me, which was very interesting. A philosopher, I love it, was a philosopher named Hoagland, a number of years ago, said synthetic intelligence is to artificial intelligence the way a synthetic diamond is to an engineered diamond. I'm sorry, is to a natural diamond. So synthetic, natural is the juxtaposition there. Because a synthetic diamond is a real diamond in that it has the same crystal lattice. It's a real diamond lattice. It's the same crystal, same carbon lattice that a real diamond. It is a real diamond, but it was not created by a natural process. It was created by an engineered process. So artificial intelligence has, from its very beginning, the whole process, the whole enterprise of it has been based, going back to the original 1956 conference, where they said in the conference explicitly that artificial intelligence is about emulating human processes, features of human intelligence. And so the end result today, if you look at GPT-3, these big language models, they have the appearance of comprehension, but not the real thing. So they are to synthetic intelligence the way a rhinestone is to a real diamond. That is, it's a kind of a cheap imitation that has the appearance, but none of the real desirable properties. So that's AICD. May it be a short-lived phenomenon. Next part, on June 23rd, we will be doing June 33rd. Is that the date? No, that's the date of the webinar. A week prior to that, in about a week, we'll put the next blog article up there. So you can go and read it. And hopefully people will read the blog articles before they come to the webinar. But either way, whether you get the blog articles will be there, and after a week after, a few days after the actual broadcast like we're doing today, the recording of it will be available on the same website in the same location. So AI and theory of the mind, and that's again very much talking about a theory of human psychology, but it's one that has huge implications, and it may be beyond the linguistic tendencies of cognitive dissonance, why humans are very prone to the kind of confusion and misunderstanding and the susceptibility to hype and deception that they are in the area of AI. So I hope everybody can join us and enjoy the article. So I was very pleased today when I was talking about cognitive dissonance to realize that one of the best ways I could illustrate the process of cognitive discipline was to use a dialogue that we actually created, which was actually a dialogue not from a human, but from one of our sapiens. And again, it wouldn't have mattered. As you can see, kind of through the thought process, humans think the same way. We don't know how the underlying process of our thoughts go, but we can see the logic. Humans go through the same logical principle when you check out your common sense or when you learn a new word. So our sapiens, and whether you call them the third wave of artificial intelligence, because they are strictly different, or the first ever synthetic intelligence, we think we have built the tool, which will continue to get better, that can extend and apply human knowledge that has the practical utility of being able to help us change the world the way we want to change it, not the way they want to do it, because they don't have that characteristic. The way humans want to apply human knowledge to make our world a better place. So we've always thought that what we're doing here at New Sapiens is using technology to help humans live lives that are more human, not to dehumanize it or to turn our decision making and everything else over to things which are not human and do not have human discernment and human characteristics. So we need everyone's support, either, and there's lots of ways of doing it. To start with, join our community. Please help us get our webinars publicized, and please tell your friends and acquaintances and family members to check out our websites, join our community and get on our mailing list. And of course, the more people know about us, the easier will it be for us to overcome the resistance or the inertia we have out there with things because of the hype, because of cognitive dissonance, because we have 5 giant tech companies spending billions of dollars on machine learning and calling it AI. And we have to break through all that, which is one reason why we have the Hypometer series on this website, Forward to the Future, and why we're doing this webinars. So the more people understand, the better educated, the better that will be for us and our success and to get the company out there. And of course, we need investors. And we're coming up with a kind of exciting new investment opportunity coming down the road, although our current one is still available. And there might be reasons why you might want to come in sooner rather than later. But in the long term, the success of the company will depend on our success on reaching more and more people. And we're asking for your help in doing that in all those different ways. Oh, and by the way, when you go to, if you read this blog article online, feel free to comment, but also if you go to and see the recordings on YouTube, give us a thumbs up, because there's algorithms out there that are looking for those thumbs up, and the more thumbs up we get, the more visitors we get, the more those algorithms are going to put us and our media and our websites and our social media and our message up in the search results. So that's how the game works these days. So help us. All right. Well, thank you very much for joining us. I hope you'll join us next week or the week after, and follow us. Thank you very much.